Have you ever thought about what the sphere's music might sound like? Although Hubble provides us with a view of the cosmos, we can also experience these astronomical wonders through other senses. For example, just listen to the majestic spiral galaxy, NGC 1300. Its arms hold blue clusters of young stars, pink clouds of star formation, and dark dust lanes. This prototypical barred spiral galaxy is believed to be NGC 1300. Barred spirals differ from normal spiral galaxies in that the arms of the galaxy do not spiral into the center, but are connected to the two ends of a straight bar of stars containing the nucleus at its center. Hubble well resolves blue and red supergiant stars, star clusters, and star-forming regions across the spiral arms, and dust lanes trace out fine structures in the disk and bar. With an area of more than 100,000 light-years, the Hoag's object galaxy is just bigger than the Milky Way, our own galaxy. The blue ring is dominated by clusters of young, massive stars, while the yellow nucleus consists of mostly older stars. Louder volume indicates brighter light, while higher-pitched light is farther from the center. A super hot, massive star is blowing an enormous bubble into space. Fittingly named the Bubble Nebula, this beautiful cosmic object is roughly 7 light-years across and resides 7,100 light-years from Earth. Scanned from top to bottom, color is mapped to pitch in this sonification of the nebula. The lower pitches of the red and orange regions are most heard at the beginning on the left and in the upper half of the bubble in the middle, while the bright blue of the bubble can be heard as higher pitches. Stars are represented by chimes, and brightness regulates volume. Approximately 20,000 light-years away from Earth is the Westerlund 2 cluster of young stars, which are between 1 and 2 million years old. Brighter light produces louder sounds, which travel across the field of view from left to right. Note pitch indicates the vertical source position in the image. Hubble data is represented by strings, Chandra's X-ray data by bells, and diffuse X-ray light by sustained tones. On February 24, 1987, observers in the southern hemisphere saw a new object in the Large Magellanic Cloud, a small satellite galaxy to the Milky Way. This was one of the brightest supernova explosions in centuries, and soon became known as Supernova 1987A. This captures observations from Chandra X-ray Observatory and Hubble Space Telescope between 1999 and 2013, revealing a dense gas ring glowing brighter as a supernova shockwave passes. Located 40,000 light-years from Earth in the constellation Columba, this globular cluster is called Caldwell 73, or NGC 1851. A globular cluster is a spherical group of stars that are gravitationally bound to each other, with most of the stars concentrated at the cluster's center. Radar scans stars, mapping radius to pitch, and converts the image to choir, orange, red, marimba, and blue, representing choir, marimba, glockenspiel, and blue stars respectively. This Hubble image of two galaxies colliding resembles a face. The eyes are the bright cores of the two galaxies, and the outline of the face is a ring of young, blue stars. The system, catalogued as AM 2026-424, is 704 million light-years away from Earth. Its sonification scans data from left to right, mapping vertical position to pitch and brightness to volume. Gravitational lensing is the phenomenon in which the light of objects located far away behind a massive cluster of galaxies is magnified and distorted by the immense gravity created by these clusters. Galaxy cluster RXCJ0142.9 provides warped glimpses of very distant galaxies that would not otherwise be visible. Sonification scans images from left to right, producing different tones for stars, compact galaxies, and sprawling galaxies. High density near the center results in mid-range tones. The center of our Milky Way galaxy houses a massive black hole surrounded by a dense nest of stars and bright clouds. Hundreds of thousands of stars, bright dust clouds, active star birth regions, and intense activity close to the galactic core are all visible in this image. Sonification scans left to right, pitching objects, adjusting intensity, converting stars, and creating drones. The lower right shows a supermassive black hole, gas and dust clouds, and a crescendo. This image of the bullet cluster provided the first direct proof of dark matter, the mysterious unseen substance that makes up the vast majority of matter in the universe. X-rays from Chandra reveal the separation of normal matter from dark matter during a collision of two massive galaxy clusters. The data was converted into sound using a pan and pitch adjustment, with dark matter data at the lowest frequencies normal matter at the highest, and cluster galaxies at mid-range frequencies. If you want to hear more of these thrilling and melodic sounds of vast space, make sure to like and sub.